Venus and Earth, are they twin planets? I'll tell you exactly what occurred. Earth and Venus are frequently referred to as different twins. Despite their significant differences, they are unquestionably the two most similar planets in our solar system. They are in reality roughly the same size, composition, and density. Venus is the solar system's second planet from the Sun. The third planet is Earth. Although Venus is closer to the Sun than Earth and hence more vulnerable to solar radiation, it was formerly in the so-called habitable zone, the region of the solar system where liquid water can exist. This is because our infant Sun was smaller and warmer than it is today, allowing for the presence of water and, who knows, the solar system's first life forms on this planet that is now so hostile. A recent study, however, appears to contradict this notion, claiming that the conditions on Venus never allowed for the production of rain and, as a result, an ocean of water. Aside from the water, some NASA simulations of Venus's development indicate that the planet has had Earth-like temperatures, which is 20 to 50 degrees Celsius for around 3 billion years. So, why is it now so uninhabitable? What caused Venus's dramatic climate change? How and why did such an Earth-like planet become so dissimilar? Don't believe the alarmists about global warming. Carbon dioxide is not to blame. Follow me and I'll explain everything. There would always be something to say about Venus, her unusual atmosphere and clouds capable of pouring sulfur compounds and triggering a slew of other horror movie-worthy events. However, keep in mind that the evolutionary history of Venus is still far from complete, especially if we go into depth, and we would therefore risk making assumptions and nothing more. So let us stick to the essentials, which are more than enough to demonstrate the fundamental characteristics of a sister who is both equal and different, and above all, let us try to debunk some fanciful interpretations of scientific institutes, which clearly only want to support the catastrophist view of our sisterhood with Venus. Indeed, it is important to recall that, contrary to popular belief, science does not always reach impartial findings. But let us go on. We previously stated that Earth and Venus were born in the same region of the solar system as virtually twin sisters, and so created from the same primordial planetesimals, with minor differences in chemical composition. In theory, these two planets should have evolved virtually identically, but even the evolution of a planet is regulated by chaos, and very slight alterations in environmental conditions can result in large differences in the final outcome. We know that if a butterfly flaps its wings in the Himalayas, it will most likely rain in Calcutta the next day. Despite the crude exaggerations applied to this notion, relatively slight variations can result in large effects over longer or shorter timescales. Both planets were produced by the cold aggregation of dust particles, first by electrostatic attraction and later by gravitational attraction as the particles grew larger. In fact, contrary to popular belief, all planetary cores develop at low temperatures. Only in the near neighborhood of the protostar in formation does the heat progressively grow due to gravitational compression of gas and dust, while the temperature remains virtually unaltered in the rest of the accretion disk. Other variables contribute to the process that causes a protoplanet to heat up. The first is the disintegration of radioactive elements locked in the core, and the second is the constant bombardment of comets and asteroids on the surface. As the surface is heated and reshaped by the impacts, heat from the core propagates more or less rapidly outward depending on the diameter and mass of the planet, and because Earth and Venus are made of the same material and have the same mass, heat propagation was very similar for both. However, after 100 million years of development, the surface crust of the two planets began to solidify, while interior heat expressed itself by supporting the ascent of magma through volcanic conduits. The initial atmosphere of the two planets, which was light and made up entirely of hydrogen, had already been swept away by the solar wind, which began to blow violently as soon as the young star succeeded in igniting the nuclear fusion process within it. Increasing volcanic activity, on the other hand, began to spew heavy gases outward, resulting in a second-generation atmosphere significantly more resistant to the power of the solar wind, which had now become fairly weak. And it was at this time that the paths of the two planets diverged. There existed a temperature differential between Venus and Earth, although a slight one. Small during the planet's early fairly turbulent and agitated phases, but large enough to be sensed as they began their slower and more regular evolution. On Earth, in fact, the rocks had quickly solidified and were forming large basins where the water brought in by comets was able to maintain its liquid state and was increasing, thanks in part to the rains that had been unleashed for millennia as the water vapor condensed due to cooling. Volcanoes continued to spew out carbon dioxide and nitrogen, but this was not an issue on Earth because a heavy gas like carbon dioxide settled to the ground and was absorbed by both rocks and the growing oceans. And in that ever less hostile environment, life began to multiply and enrich the atmosphere with oxygen one day, even if it was a process that lasted 1,000,000 years, don't you think? And what about Venus? Unfortunately, cooling took much longer on Venus. The rocks remained semi-fluid and extremely heated, and they were unable to accept and retain the water brought by cometary impacts. Under those conditions, the liquid could do nothing but transform into a gaseous state in the form of water vapor. Although the sun was 30% fainter than it is now, this would not have been enough to lower the temperature of the young celestial body sufficiently to allow the formation of seas. To give rise to enormous swaths of water, the temperature of its atmosphere would have had to drop sufficiently for the liquid to condense and fall as rain over thousands of years, as it did on Earth. To summarize, contrary to popular belief, oceans of water never formed on Venus. Instead, a thick cloud of vapor grew over the entire globe, obstructing the heat that rose from the ground and attempted to escape into space. The already warm soil began to heat up even more, and what little water had been saved in the colder areas also went to gas, contributing to a more bizarre greenhouse effect cycle. The feeling is similar to being in a greenhouse or driving with the windows closed. If Venus had no atmosphere and its surface could freely reflect solar energy into interplanetary space, it would have a surface temperature of 100 degrees Celsius, significantly lower than the actual 400 degrees Celsius. If it could have formed a normal atmosphere, Venus would today be a planet with an average temperature of 40 degrees Celsius. In reality, in addition to the greenhouse effect induced by water vapor, there was also the tragedy of extremely active volcanic activity. In reality, the magma that erupted from the volcanoes began to emit massive volumes of carbon dioxide that, unlike on Earth, could not be absorbed by the non-existent oceans. And these gases couldn't fall back to the ground because it was now too hot, so they wandered off with the water vapor that was now departing the planet, blown away by the solar wind. As a result, the atmosphere became a dense, toxic molasses made almost entirely of carbon dioxide. At this time, ground temperatures had approached the melting point of lead, sealing the planet's fate. In short, if you have followed me this far, you will have realized that the true cause of the greenhouse effect, which ruined the wonderful planet that Venus could have been, was not only the excessive increase in carbon dioxide, but also, and most importantly, the fact that at some point in its history, the surface temperature did not decrease sufficiently to allow the accumulation of water and the formation of oceans. The massive amount of carbon dioxide generated by the volcanoes would then have been absorbed by the oceans. Basically, the greenhouse effect was created by a shortage of water. Some of you may argue that we just stated that the lack of liquid water was caused by Venus's crust being too hot, forcing it to evaporate. As a result, it is unclear why Venus's crust has not cooled as much as that of Earth. And it is true that the excess heat of Venus' crust can be explained in part by the planet's increased proximity to the Sun, but there is more. Venus, unlike Earth, lacks its own plate tectonics. The lubricant that keeps the continental plates moving is missing. In simple terms, water seeps into the interior of the crust and mantle on Earth, allowing the surface zones to shift relative to the fluid zones below, giving rise to the well-known continental drift. The water on Venus was swept away by the solar wind when it mattered, and the movements halted or never started, like an engine that forgot to add oil. Unfortunately for Venus, tectonics is crucial in regulating the amount of carbon dioxide in the atmosphere. Tectonic movement really shifts rocks and brings new ones to the surface. Silicates, minerals made primarily of silicon and oxygen atoms, make up the majority of Venusian and terrestrial rocks. Silicates capture emitted carbon dioxide and transform it into other compounds that do not contribute to the greenhouse effect when they come into touch with it. In brief, if tectonics do not exist, the produced carbon dioxide will not be absorbed and will continue to generate the greenhouse effect. And this brings us back to what we said at the beginning: don't believe anything that so-called official science asserts. Many have used the tragic narrative of Venus, which went from a promising garden planet to an inferno, as an illustration of what could happen to the Earth if mankind continues to release carbon dioxide into the atmosphere. While warning people not to pollute and to preserve the environment is somewhat justified, I do not believe it is appropriate to terrorize the globe by implying that our planet may follow in the footsteps of its previous sister planet. Beyond the minuscule quantity of carbon dioxide that humanity will be able to add into the atmosphere, astronomical and geological cycles have always led the Earth through dramatic eras and will continue to do so. Amounts sufficient for a few good volcanic outbursts to equal an amen. And be sure, when they try to sell Venus to you as a mirror of our future, don't forget to remind out that the temperature rise was caused by a paroxysmal phase of volcanic activity, which the lack of water couldn't fix. Not carbon dioxide, but the varying amounts of water sealed the fates of the twin planets.